Right. So this is a particularly hard question on moles, and it's targeted. It's in the 8 to 9 targeted grade workbook. So we've already had a previous question on it, and it was about this unknown catalyst, which has the formula of XOA. So XOA. So that could be XO2, could be XO3, but within the formula there is one lot of X, one atom of X in each. If it was a covalent compound, then one atom of X in a molecule, and we don't know how many atoms of oxygen in the molecule, but there are a lots of oxygen atoms within the molecule if it was a covalent substance. Otherwise, we just talk about it in terms of ratio. Yeah. So I guess we would say something like X to O is the same as 1 to A. Okay. So A could be 1, A could be 2, A could be 3. It's got to be an integer, of course. It can't be a positive integer, obviously. But other than that, we can't say much. We can't say much more. So the catalyst can be reacted. So it's saying you can react it with oxygen gas. So let's just move this out of the way for a moment. So the reaction would be XOA plus oxygen produces. Oh no, sorry. Let's try that again. It can be made with that. So I'll just finish that off. It was actually X reacting with XOA to produce. Sorry, start again. X reacting with O2 to produce XOA. So, and this is quite a tricky question, but what we worked out eventually was that just by looking first, okay, so we don't know how this equation is balanced, all right, which is part of what the question's asking us to do. So, it could have one lot of X, two lots of oxygen, and we don't know, all right? Well, what we do know by looking at it carefully is that on the left-hand side, we have X's, and on the right-hand side, we have X's. So this one and this one, this number and this number must be the same. It has to be the same because the X's are only in one substance on the left and only in one substance on the right. So you have to, in order to balance it, that number and that number must be the same. We don't know what that number is because it depends entirely what A is. But what we do have is the masses of some of these substances. So we've got the mass of X over here. Oh, that's not much good. Let's just do some color coding so we can visualize this a bit better. So we've got yellow for the XOA, pink for the oxygen, and then the X is green. And what we have is we know that we've got 14.1 grams of X in excess oxygen. What we want to know is how many grams of oxygen would have reacted, but luckily we've got the mass of XOA over here. So that means that if that many grams of XOA was produced, then if we minus 17.65, if we did 14.1 minus 17.65, then that remaining mass must have been the oxygen. So if I delete this rectangle here, we can start to work out what we did here. So here's the, I'll use a bit of highlighters here. So here's my mass of oxygen that I worked out. Now I know the molar mass of oxygen is 32. So 3.55 as a fraction of 32 would be the number of moles. So there's my moles of oxygen. And I did the same with the XOA. In the previous part of the question, we were told that the molar mass of XOA is 79.5. So we can do that. Let's, I just did the wrong color, didn't I? Okay, so that is this one here. So yeah, so that's 0.2 moles. So it's the mass as a fraction of 79.5 grams molar mass. So if I get so it's going to be want to do green for this. And so what I did is I did the 79.65 take away 14.1, and that was working out the oxygen. So that gave me that, divided it by the molar mass to give me the moles. And now that, and this was really the key to doing the rest of the question, really. We saw that the molar mass, the moles of oxygen to XOA is 1 to 2. So, in which, and we know that already the ratio of X to XOA is 1 to 1. So that would mean that, well, basically we've got, all in all, the ratio is going to be, well, where's X? It's going to be 2. Oops. If we switch these around because we've got the, 1 to 2. Okay. So, yeah. So 1 to 1 is the same as 2 to 2, of course. So we could say 2 to 1 to 2 would be the ratio of the X to O2 to XO2. So, and that's essentially what the balanced equation would be. So if I color these in, then you can see the X to the OA is 2 to 2, which is the same as 1 to 1. So that's the one there. And the oxygen is the 1 in the middle. And that means that because, and we got that because we know the ratio of that to that is 1 to 2. So we've got a balanced equation now because we know it's got to be 2, 1, 2. And if that's the case, the only way that we can have that is that A would have to be just 1. In other words, the formula for XOA is just XO. So the formula ends up going like this, because if it didn't, it would, well, that's the only way that we can have that as a balanced equation. 2x plus O2 goes to 2XO. So I did an example, would be like 2 times magnesium plus O2 goes to 2MgO. So the balanced equation is 2x plus O2 goes to XOA, where A is equal to 1.